And here we are at Algebra 1.3, solving linear equations with variables on both sides. Things are just getting progressively more complicated, as they do. So, up till now, all the equations have had x sitting on the left-hand side, and all we had to do was get all the numbers on the right-hand side. Now, x is going to be on both sides, and we're going to have to manipulate both sides of the equation to isolate x. So this example has -2, 1 minus 7x, parentheses, equals 5x plus 34. Okay. So first thing we got to do is distribute. We have -2 sitting outside the parentheses, so we've got to distribute it into the parentheses. -2 times 1 is -2. -2 times -7 is positive 14, right? Because negative times negative equals positive, equals 5x plus 34. Okay, now we have to decide which thing we're going to do first. What we've got to do is end up with this x on the left-hand side and this number on the right-hand side. So we're going to do either one of them first. I'm just going to decide arbitrarily to do the x first. Minus 5x minus 5x. 14 minus 5 is 9. That's 9x. Okay, so that's taken care of. Now I'm going to add this 2 because it's being subtracted, so I need to do the opposite of it to get rid of it. So that becomes a 0. Add the 2, add the 2. 9x equals 34 plus 2 is 36. And if we know our 9 multiplication table, 36 divided by 9 equals 4. And we're good. See, it's not as hard as it seems. Yet. Alright, this one's got a fraction. 3x minus 1 equals 2/3 x plus 13. Okay. I'm gonna start with this 1 first because it seems easier. Plus 1 plus 1. 3x equals 2/3 x plus 14. So now I have to work with this 2/3 x. Minus 2/3 x minus 2/3 x. 3 minus 2/3 is going to equal 2 1/3. Let me take a second to work out why. 3, any whole number is the same as itself over 1, right? So 3 over 1 minus 2 over 3. This is going to take longer than I thought it would. I got to multiply this by 3, so that's 9 over 3 minus 2 over 3 is 7 over 3. Okay, 3 goes into 7 2 times, right? Because 3, 6, 9. It doesn't go all the way up to 9, so we stop at 6. So that's 2. And then 7 minus 6 is 1 over 3. 2 1/3. I hope that made sense. Back to this. Like magic. So that was 2 1/3 equals 14. Oh, that's 2 1/3 x equals 14. Let's leave that actually as 7/3 x. I think that might be easier to work with. 7/3 x equals 14. Okay. Divide by 7/3. Divide by 7/3. Now, if you remember, dividing by a fraction means you flip the second fraction and multiply it. So we're going to go 14 over 1 times 3 over 7. Okay. 14 times 3, well, look at this. 14 divided by 7 is a pretty easy division. I'm going to do that. 14 divided by 7 is 2. So that's going to be 2 over 1 times 3 over 1. So that's 2 times 3 is 6. And our answer is 6. I hope it makes sense the way I got there. I hate fractions so much. All right, example number 3, 5.2x plus 3.6 equals 3.2x minus 1.4. Is that all on screen? There we go. Okay. What we want to do first is move this 3.2 over here. Minus 3.2x minus 3.2x. 2 minus 2 is 0. 5 minus 3 is 2. 2x. Okay. That's taken care of. That's taken care of. Now I'm going to subtract 3.6. Subtract 3.6. These are both negative, right? So I'm just going to add these numbers together. 6 plus 4 is 10. 3 plus 1 plus 2. 3 plus 1 plus 1, I mean, is 5. We're going to keep this negative. 2x equals negative 5. Divide by 2. Divide by 2. X equals 2.5. Or we could leave it as 5 halves, or negative 2.5. But since they were dealing with decimals up here, we're going to keep using the same terms they used. So we can put it in negative 2.5. Okay, now we talk about a special circumstance. Special circumstance where the x's, the variable, get rid of each other, and they go away. For example, 2x minus 5 equals 2x minus 5. If you subtract 2x and subtract 2x, it goes away, and you end up with negative 5 equals negative 5. This is called infinitely many solutions, because you can put in any number for x between 1 and infinity, and the left side will equal the right side. There is no one solution for x. It's every single imaginable number, infinitely many solutions. The other version is called no solutions. That's 3x plus 6 equals 3x minus 2. If I subtract that 3x, subtract that 3x, I end up with 6 equals negative 2. And 6 does not equal negative 2. That's a lie. So it's no solutions. There are no solutions that will ever make this equal that. No solutions. Let's look at their main example that they want us to figure it out from. Of course, it's big and complicated. 3 parentheses 2x minus 3 equals x minus 9 plus 5x. And they want us to figure out if it's going to be infinitely many or no solutions. We don't know yet. So let's see. 5x plus x is 6x minus 9. 3 times 2x is 6x minus 9. See how that's the same term? 6x minus 9, 6x minus 9. That's infinitely many solutions. If you can get it down to where one side equals the other side perfectly, then that's infinitely many solutions. Let's look at the next one. 3y minus 4y minus 2 equals 2 minus y plus 10. Okay. 3y minus 4, 3y minus 4y minus 4 minus 2 becomes positive 8 equals 2 minus y plus 10. 3y minus 4y is minus y plus 8 equals negative y plus 12. Now we've got this negative y equals this negative y, but 8 does not equal 12, so this is no solutions. Okay, now we go to word problems. A square and a triangle have equal perimeters, right? Okay, so perimeter is the measure of the outside lines added together. So that means this triangle is probably slightly bigger than the square. Ignore my drawing, I guess. But let's say if this was 1 and 2 and 3, that would be 6. That's terrible. 2, 2, and 4. There we go. If it was 2, 2, and 4, then that would be 2, 4. That'd be 8. Then you could make this 2, 2, 2, and 2, and they would be equal. See, that's kind of what we're getting at, is they have the same perimeter. Except in the equation they give us, it's 4p minus 2 equals 2p, or not 2p. That is the question. Whether 'tis nobler in the mind to suffer the slings and arrows. Never mind. 2p plus 16. By the way, without you guys in the room, this is slowly driving me crazy. I need you guys back. Anyway. 4p minus 8 equals 2p plus 16. I didn't put the p. There we go. Minus 2p minus 2p. Oh, come back. We end up with 2p minus 8 equals 16 plus 8. That's an 18. 16 plus 8. 16 plus 8 is 24. 2p equals 24. Divide by 2, divide by 2, and p equals 12. Now, that is not the end of the problem, because the way the problem is phrased, it says find the perimeter value, which means we have to take this p equals 12 and put it back into one of those original equations. I'm going to do 2p plus 16. P equals 12, so I'm going to take this 12 and put it in here. So 2 times 12 is 24. 24 plus 16. 6 plus 4 is 10. 2 plus 2 is 4. 40 is our actual answer. I'm going to scroll down and look. And 40 equals 40. I'm a genius. You're welcome. You're welcome. Thank you. Thank you. Thank you. Okay. The sum of 4 consecutive integers is 27, more than the lowest of the integers. What? Okay. The sum of 4 consecutive integers. So, x plus 1, x plus 2, and x plus 3, those are 4 consecutive integers, right? We don't know it yet. X plus 1, x plus 2, and x plus 3. Those are 4 numbers in a row. Like if this was 2, this would be 2, 3, 4, 5. If this one were 4, this would be 4, 5, 6, 7. I hope that makes sense, because that's the only way we're going to be able to move forward. Okay, so that's 4x, 1 and 2 is 3, 4x plus 6 equals, is 27 more than the lowest of the integers. X is the lowest of the integers, so that's x plus 27. Holy crap, I think I figured it out. I think this is how they wanted me to do it. Us, you, them, anybody. Okay. Minus 6, minus 6. 4x equals x plus 21 minus x, 3x equals 21. Divide by 3, divide by 3, x equals 7. Huh. Is that right? Is that what they wanted? X equals 7. Huh. Neat. And that does it for section 1.3. Join me next time. Same bat channel, same bat time. I'm not Batman. Why would I say that? Batman's not even cool. Like Iron Man. Iron Man's much better. Anyway, see you in section 1.4.